Wasn't it thanks to the terre production that you succeeded in your last technical itinerary? We need your financial help to make these videos. Please support us by making a donation via the Type link.
Marc-André, hello. You are a biologist specializing in botany and more specifically in mycology. Today you are a professor at the Museum of Natural History and you are one of the specialists in microbial life, particularly symbiosis, also known as mutualism in short, the interactions between microscopic living beings and plants. Can you tell us a little more about that?
So, well, I work on the interactions between soil, fungi, and plant roots, which of course there are some pathogens, but many of these fungi are actually beneficial to plant life. These fungi include, for example, porcini mushrooms or chanterelles in the forest, and also truffles for trees. But all plants have associated fungi that help them feed and defend themselves in the soil. This is really a general rule that we are just beginning to understand. And so my teams at the Museum of Natural History, but also at the University of Gdansk in Poland and in China, in Kunming, are working on these associations, trying to understand their ecological functioning, their role, their diversity, and all of this from an evolutionary perspective as well, how all of this has evolved and adapted to different environments.
Today, there's a lot of talk about biodiversity. And the more we dig, the more we realize that this biodiversity is also very much beneath our feet. There is an enormous variety of different species in the soil. We talk about soil life. What exactly does that mean?
It's simply the life of terrestrial ecosystem. In reality, what we see on the surface is just a few bits of plants and a handful of small creatures running around. But terrestrial ecosystems, biodiversity, are found beneath the soil. 25% of known species are in the soil, and it's still largely unexplored. There's just one problem with soil. For one thing, it isn't transparent. We often don't realize, for example, that a third of a plant's biomass is actually underground, mostly in the form of fine roots, simply because the soil isn't transparent. And then, life in the soil is also largely microscopic. Most of the animals that make up soil diversity are creatures less than a millimeter in size. And then there's this whole teeming microbial world, fungi, bacteria, amoebas, ciliates, and all sorts of things we can see with the naked eye. Soil isn't transparent, and the life within it is too small to see, keeping us from realizing biodiversity is right there. But there's not only biodiversity in terms of species here, but also a biodiversity of function. So what is soil really? It's mineral matter that is gradually breaking down, decomposing, to restore the soil's fertility. It's the microbes that do this. They're the ones in charge of breaking down the rocks. It's organic matter that is being transformed to release fertility or to create humus. It's the microbes that do this. And then it's also about exchanges with the atmosphere. The nitrogen in the soil comes from atmospheric nitrogen. That's what creates the nitrogen stock in the soil. And again, it's microbes that do this. So it's also a functional diversity. And here, we actually come back to the major functions of terrestrial ecosystems. So even functionally, life in the soil is terrestrial life.
In agroforestry, we focus on the tree, and in fact, on the tree at the heart of the crops. So we can imagine that the tree ultimately provides various services to our crops. We often talk about this famous mycorrhiza. What exactly is it, and what kind of service can it provide to our crops and to the tree?
Reintroducing trees into our annual crops or into our shrub crops, let's say, means restoring the complexity of the ecosystem. We have greatly simplified our ecosystems in the context of agriculture. Because in the short term, it can be profitable, but in reality, we realize that in the long term, certain functions are missing. So reintroducing trees means recovering a number of those functions. And contrary to what people think, it's not just about competition, because the tree, both in the soil and in the air, uses different resources than those used by the crop growing underneath. So obviously there is a bit of competition, but there is also access to things that wouldn't be used otherwise. And there are teams in Montpellier who have clearly shown that when you practice agroforestry, you can produce up to 1.5 times more biomass than if you only do forestry or only cereal farming, for example. So there is this idea of creating synergies and of recovering other functions by making the agroecosystem more complex again. And this will have microclimatic effects. It will allow us to access water deeper in the soil. But also, there are indeed interactions due to the fact, for example, that we can have the same fungi associated with the roots of the trees and with those of the crops growing underneath. And this can create synergies in maintaining a common good, which is the entire mycorrhizal network. But that's not all. There's also all the organic matter that we add to the soil, especially if we prune these trees or leave their leaves on the ground. And this organic matter is something that feeds the microbial life in the soil, which in turn enables the development of plants. So yes, in fact, it's the promise of synergy and of moving away from a vision that's ultimately focused only on competition within ecosystems, which does exist, of course, but not on its own, and instead rediscovering synergies to produce more, meaning also with more ecological functions.
And for example, could we imagine in the context of global warming that this mycorrhizal network might play a role in redistributing water, or in the idea of drawing water from farther away and more efficiently?
So yes, one of the hopes, indeed, aside from the microclimatic surface effects, which by the way can be mixed, because there can be negative effects like the accumulation of cold air pockets and the promotion of late frosts. So all of this is a tool that we need to decide how to use in the best possible way. But indeed, we have this hope regarding the soil that roots will go deeper to find water and perform what we call hydraulic lift. That is, the water rises and part of the water that moves up through the roots ends up being drawn into the dry surface soil. And there, it serves as a resource for plants with shallower root systems. Eventually, in fact, this flow that can occur through the soil may happen via mycorrhizal fungi shared between these trees and the crops we've planted underneath.
So when we talk about these microbial interactions, it's essentially about sharing a common good. How can you, as a biologist, and how can we, as farmers, make sure that it really is an exchange and not a case of parasitism where...
So that's really the central point. This mycorrhizal network, the fact that fungi can colonize several plants at the same time, sometimes even of different species, well, it's like everything in the living world. It's neither good nor bad. It just is. It exists, and it's up to us to find the right approaches. So these mycorrhizal networks are really a point of focus for my research teams, because we work a lot on this. We don't see mycorrhiza as a one plant, one fungus interaction. We see mycorrhizae as plants connected in a network by shared fungi, which ultimately interact with each other. And also, let's be careful not to be too superficial in how we see things. It's also fungi connected by plants, Fungi aren't just pipes. They're also organisms with their own evolutionary logic. And sometimes that actually leads them to do things that plants don't like. So in fact, our research mainly focuses on understory plants that manage to survive in the shade by drawing photosynthesized carbon from trees through shared fungi. So much so, in fact, that some of them have even become non-chlorophyllous. Here, we can clearly see that the network is being used by freeloaders. Let's call them freeloader 7, though these plants are absolutely fascinating to study. On the other hand, there can also be beneficial effects. In forests as well, we observe nursery effects, meaning that the fungi previously paid for by the trees which have nourished them before will be available for seedlings that arrive and connect to fungi whose development they could not afford on their own. So there are both synergies and competitions, and that's what we need to identify. There are studies showing that for grapevines, for example, you can very well have nitrogen flows from the cover plants when the vineyard is grassed, especially with nitrogen-fixing plants going towards the grapevines. But it can also be shown that in other circumstances, the nitrogen flow can be reversed if the cover crop draws nitrogen. Here, it's clear that the management of the cover crop, especially the proportion of nitrogen-fixing plants, will determine if exchanges are beneficial to the grapevine.
Yes. So you need to have knowledge in order to manage, organize, and properly guide each of these crops according to your soil type and climate.
Exactly. In fact, we've put a tool on the table, and now we need to develop the technical approaches that go with it. Just as in the 19th century, when mineral fertilizers were discovered, it took decades to figure out how to use them properly. So it's true that it's a bit disorienting because today we have something that is a potential tool and could actually replace practices like the overly frequent application of mineral fertilizers whose limitations we are now seeing. But we really do need to develop technical approaches. And we can't believe in the concept of terroir while thinking that the same practices will work everywhere. In fact, each person, each region, or each type of crop needs to find the practices that are appropriate for them. So there is still research to be done before this becomes routine. But clearly there is hope to renew agriculture and ultimately transcend the limitations of what we've inherited.
So precisely, these practices, for us as wine growers, which actions or agricultural practices might impact soil life, whether positively or negatively? What am I doing on a daily basis that could affect the life and fertility of my soils?
That's a real question. Well, there's already a list of things we know aren't so good. So what isn't good? Plowing, in the sense of turning over the soil, not just aerating it, but turning it over too frequently. That, for example, tears apart the fungal filaments. You can clearly see, for instance, birds rushing in to eat all the worms that have come up to the surface. That's basically the image of a Holocaust, So plowing, not on a recurring basis, which doesn't mean that sometimes on certain soils, you can't or shouldn't decompact the soil. Pesticides, for example, which have terrible side effects. Well, it has to be said, glyphosate, which today we find hard to do without, in our current view of agriculture, something that kills earthworm cocoons and destroys mycorrhizal fungi, those famous fungi that interact with plant roots to help them absorb nutrients from the soil. So here we're really talking about practices that should be reserved for exceptional cases. We can't use them repeatedly again. That's the idea. We're not depriving ourselves of anything, but we avoid repetition. And then there are fertilizers, because in the end, those mycorrhizal fungi I mentioned help the plant feed itself in the soil. But if the plant has access to a lot of nitrogen, a lot of phosphate, a lot of potassium, well, it will take them up itself without helping the fungus, without feeding the fungus. Since in mycorrhiza, it's an exchange of mineral salts for sugars. It's cheaper for a plant in rich soil to feed itself than to feed the fungus. So we know very well today there are some excellent studies showing that when we add fertilizers, in fact, we increase the potential for parasitic microbes compared to the potential for microbes that are beneficial to plants, because the plants no longer feed the beneficial microbes they no longer need. When we get to this point, it feels like ecology is forbidding us. But that's not true. It actually opens up new possibilities. And in a way, the farmer actually has plenty of ways to manage the soil. For example, for 2 or 3 millennia, farmers have been managing the populations of nitrogen-fixing microbes in the soil. How do they do it? Well, they plant green manure, legumes, which themselves encourage these microorganisms and thus promote the conversion of atmospheric nitrogen into nitrogen that will work and be exchanged in the soil. And I think that's the future. To rediscover the practices, the actions on the soil, the actions on the plants we choose, cover crops, interrow cultivation, to rediscover practices that are in the farmer's toolkit, actions on the plants, actions on the soil, and that have beneficial effects on the soil microbes. I'm not at all saying that we need to turn farmers into microbiologists.
So we need to rediscover those practices that respect soil life and ensure that what has always happened in the soil continues to happen.
To use the traditional tools and levers of agriculture in the service of a new vision of soil sun that promotes life and doesn't keep soils on life support. I can survive with a glucose drip, I can live, but that's basically what we've done to the soil with inputs. And the idea is to get back to a different logic, to return to a local logic. It's also about saying that there is no universal solution and there are no universal prohibitions. We need to rediscover in each farming region what is suited to the soil and the climate.
Ultimately, this helps us understand that today, perhaps the farmer is becoming an important player in the production of biodiversity. And what we take away from your absolutely brilliant talk, Marc-André, is that if we want to talk about biodiversity now, we also need to start looking beneath our feet.
Urgently so, yes.
Thank you very much.